Good morning. So, this is a talk that is about 45 minutes long. Actually, it's about 90 minutes long, but I have 45 minutes. So let's see how this one goes. There's a lot of stuff here. So, metaphors we code by. This word metaphor comes from the Greek, metaphora. It means transfer. If we look in the Oxford English Dictionary, it gives us the kind of full blurb. The figure of speech in which a name or descriptive term is transferred to some object different from, but analogous to that which is properly applicable. In other words, it's a mapping. We are describing something else, we are describing something in terms of something else. Now, why do we do this? Historically, people associate metaphor with poetry. And certainly that's the way that it was taught at school for the bits that I was awake. But it turns out it's much, much deeper than that. In software, although there is art and poetry in software, that's not why we use it. We describe things that are fundamentally abstract. In fact, I accidentally just kicked something on the stage here, which is a nice coincidence. Because I often describe the frustrations of software as the fact that we are dealing with non-kickable stuff. Okay? If a device frustrates you, it's kickable, it's also throwable. There's a metaphor already, exceptions, we throw them, yeah? I think if we kicked exceptions, that'd be much more rewarding. But the software is not kickable. It's not stuff you can hold in your hand. The thing is that humans are really good with physical stuff. We're really good at that. When we talk about all these things we struggle with in software, the size of things, the pace of things, our progress, my goodness, how do you measure progress? Think of your estimates as well. We always struggle with these. There are a number of reasons we do, but one of them, not the only one, but one of them is the fact that it's not physical. Okay? Now I don't actually have a glass of water here, so I'm going to invite your imagination. I have in this hand a 200 milliliter glass. You see it? Yeah, good. Yeah. It's kind of empty, isn't it? It's good. I have in my left hand a jug that is 1 litre capacity, and it is full. And now I am going to empty all of this into this. Is that going to work? No. Well, I mean, it'll ultimately work. I'll get wet, you'll laugh. But the point there is, how did you do that? You look at the thing and you go, well, that doesn't fit. Are you some kind of like fluid dynamics expert? Are you volumetrics experts? You're human. You get this skill for free. Yet you can be developing software for decades and still get your estimates and sense of progress wildly wrong. We try and use various points to help us with this. We invent paradigms to help us think in these things. A paradigm is ultimately an illusion. It's an illusion of choice. And we like to turn things around. It turns out this is fundamental to the way that humans think. Now, this is a book that I found incredibly useful a few years ago. It was published in the late 70s. In fact, you can actually tell it was published in the late 70s just by looking at the cover. People don't produce covers like that anymore. This has got a real old school feel to it. Metaphors We Live by George Lakoff and Mark Johnson. Their thesis was that actually metaphor is fundamental to language and the way we think. It's pervasive in everyday life, not just in language, but in thought and action. The essence of metaphor is understanding, experiencing one kind of thing in terms of another. And then they gave you systems of metaphor in the book. They gave you lots of examples. It can be quite a dry read, but I found it incredibly rewarding. Examples. Now, obviously, a lot of metaphors are based on culture and language choice. This is not true. What I'm saying here is not necessarily true of other languages. If we switch to Chinese, then we're going to find that the metaphor systems are different. But argument is war. When we think of argument, two people arguing, if we think about it in terms of war, that gives us a language. It gives us the idea that she defeated her opponent. Defeat, that's the language of war. Okay? He attacked her position. Attack, that's the language of war. It gives us a framework. Time is money. Well, we kind of know this one. You even have it littered through the English language. How are you spending your time? You can't spend time. You can spend money, but if you pause for a moment, you can't actually spend time. That doesn't make any sense. It does make sense. Happy is up, sad is down. This is a really strong cultural one. But it's through the language. How you feel that? Oh, a bit down. Oh, I'm feeling really up. People don't sit there and go, oh my goodness, he's using a system of metaphor. I wouldn't know. Love is a journey. Where is this relationship going? Over this way, right? You see, that we're trying to describe things that are non-kickable. Not that we want to do this in love, but we're trying to describe these things. It's not just a language of poetry. Oh yeah, arguments and buildings, that's another nice one. If your argument, we talk about it's well structured. His argument collapsed. That's not the language of war, that's the language of building. So there's a whole system here. Now, what I found interesting is this book was published in 2008, Andy Hunt. Pragmatic Thinking and Learning, he talks a bit about metaphor. What I found interesting is that he identified all the same metaphors that I personally identified before. What we call windows on the computer screen aren't really windows at all. And you have a desktop. The biggest difference between my desktop and my desktop is that my desktop on that device is clear, it's pristine, it's beautiful, it's well organized. My desktop at home is chaos. It is structured in terms of sediments. If you dig deep enough, you get back to the Cretaceous era and you find the dinosaurs. Everything is carefully, accidentally organized. But Windows, it also gives us a language. You can open Windows and you can close Windows. Yeah? You don't attach to Windows and detach, that's not the language of that. You open and close them. But we already start getting the sense that it's not perfect. Have you ever tried resizing a window? It's very expensive. My wife and I did it in the last house we were in. Okay? So clearly it's not exactly a match. Another one that I always use is talking about folders. It's not a real folder. Then we also discover something else. The trash can. So here's the interesting thing. Just by doing this, I know that Andy is a Mac user, because he's talking about the trash can. I'm a Windows user, I talk about the recycle bin. Why is it a recycle bin on Windows and a trash can on Apple? Now, when I ask most people, they give an answer that sounds really plausible, but is actually wrong. Oh, well, because Microsoft wanted to be different. No, if they wanted to be different, they could have done a lot different. When did Microsoft introduce the recycle bin? Anybody know? Which version of Windows? 95! I wonder what year that was released in. Oh, yeah. The Mac is 1980s. Recycling wasn't a thing. People didn't have recycle bins. That was not a cultural thing. The 1990s, that's when we started having recycling as a thing in the West. So it also, what we find is some metaphors are frozen in time. They capture a moment in time. Threads, you're not sewing. As Andy says, it's just a metaphor. Now, my own personal journey into thinking about metaphor started with network. Not any of these other things. These things came after. So, I worked, in the early and mid-90s, I worked in the water industry, then I worked in the electricity industry. It wasn't until I worked in the electricity industry that it suddenly struck me. I was working on a product, and it was one of those, you know, in films you kind of see kind of a power station or electricity distribution control rooms, and you have these multi-headed workstations and these big displays showing the whole electricity network, and normally something's crashing somewhere and there's a terrorist attack. It's not that exciting in the real world, but in movies you normally have these kinds of displays. Well, I worked on one of these. And I remember sitting, looking at the source code one day, realising, wait a minute, we have 4 classes that are called something network. And at that moment, I kind of suddenly thought, hang on, what's going on here? Yeah, we've got 4 different kinds of network, and they're all different. One of them was, of course, the electricity network, which clearly has just gone down. Coming back. Oh, there you go, that's the blue screen of life. And, yeah, why are you doing that? This is exciting. So anyway, let's just talk as if there was something out there. So, that network that I first encountered was the electricity network. Then there was network, the graph data structure. Then we had network, the TCP/IP network. And then we had the idea of that power spike really did not, poor thing. That's right. And then there was a 4th network. I don't remember what that was. But at that moment, I thought, wait a minute. All of these are networks, and not a single one of them is a network. Now at this point, I actually need to have something on the screen, because I was going to give you the definition of network. But, just a moment, we're almost there. Okay, let's just work with that. So, at that point, it occurred to me, hey, there's all this stuff. That's not really stuff. And when we talk about network, the real definition, the original, I don't want to say real, but the physical definition, work in which threads, wires, or similar materials are arranged in the fashion of a net, especially a light fabric made of net threads. This is not how we use this phrase in English anymore. It's almost an obsolete term. In other words, when we say network, by default, we think the internet, we think social network, we think rail network. All of these are metaphors. The original one is almost dead. So, this is a point that inspired me when we were writing this book, Pattern to Software Architecture. I wrote this: the aphysical, invisible domain of software is more about metaphor than matter. We don't really deal with the physics of stuff in the same way. Physics does, of course, influence the stuff, but not the same way. Now, this inspired, at this point, around this time, myself and Andy Longshaw did a couple of workshops. One at the European Pattern Languages Conference, 2006. We did a focus group, Metaphor in Software Development. Then we did another one the following year at the Spark Conference, 2007. And we got people to kind of explore metaphors. One of the things we discovered is that, yes, these are pervasive. One of the other things we discovered was we kind of choose some of them, but sometimes they're a little bit surprising. Let's look at this one. Double canoes. Trees sprout up just about everywhere in computer science. Yeah, they do. Except, this is how we do trees. I remember telling my kids, when they were a little bit younger, and they were kind of interested in, stuff. And I think I'd said at lunch, or something I just mentioned, oh yeah, a tree. They go, what? I said, yeah, trees, we have trees. It's a directory tree. These are all trees. Oh. And by the way, in software, if you get into software, my younger son had expressed an interest in software. If you get into software, you'll discover that we have the roots at the top and the leaves at the bottom. And my kids are there, you're joking. And this is one of those things, because eventually you get to that point when kids go, you are kidding, this is a joke, it's not real. I said, no, really, this is what we do in software. It leads to the wonderful but important observation. A metaphor will never map its target perfectly. As you can see, it's not an identity. Metaphor is not identity. So be very careful, because sometimes I get people saying, oh, but that metaphor it's not perfect. Well, of course it isn't. That's why it's a metaphor. If it were perfect, then it would be it. There wouldn't be any transfer, there wouldn't be any mapping. It is it, there's no discussion. So you will never get perfection in a metaphor. That's fine. That's what they're about. When we talk about love as a journey and argument as war, we're not actually expecting every single term applies precisely. We find surprises. There's a wonderful observation from Tony Moore about trees. You cannot teach beginners top-down programming because they don't know what genders are. In the real world, trees are green. They're not black and white as I've shown here. In software, do we have colours on trees? Yeah, we have red-black trees. That's as close as it gets. It's kind of also, and then we have these kind of wonderful plays on this, XKCD. It's a Christmas tree with a heap of presents underneath. Yeah, we're not inviting you home next year. But it creates, there's intelligence to this. It creates a system of vocabulary. Root, trunk, branch, leaf, these are all terms that we use. In other words, with a metaphor, you get a whole lot of other stuff. A metaphor is not being isolated. And that's another thing that's covered in the lack of Johnson one. Metaphorical entailments can characterize a coherent system of metaphorical concepts and a corresponding coherent system of metaphorical expressions for these concepts. They give you a language to work with. They give you a system of meaning. Of course, it's not perfect. That's where ultimately, when we're building systems, there's a lot of negotiation. But there's a couple of other things that are interesting. It does give us a vocabulary. It gives us a vocabulary for talking about pancakes. Now, at this point, I could talk about sorting algorithms. You may not know, but there is actually a pancake sort. You might have been at university, you might have been taught quick sort, merge sort, but there is a pancake sort. I'm not talking about that. I'm talking about the fact that this is a stack. Possibly the most over-specified abstraction in the history of computer science. How do we talk about it? Size, yeah. Count, yeah, that works. What about length? No, not at all. A stack is a vertical concept. It's not a horizontal concept. A queue does not have a height. A queue is a horizontal concept. It can have a count, it can have a size, it can have a length. It does not have a height. And it does not have a depth. Now, here's an interesting one. Both height and depth work. But actually, in software, we favour depth. We favour the idea of a push-down stack. I did deep research. I did Google. Okay, but I also listened to the way that people talk about it. People are more likely to talk about depth and go deep than they will about going high with the stack. It's very unusual. It's not unknown, and it does make perfect sense. It's just we've culturally veered towards the idea of depth being a more natural way of talking about it. This stack has a top. So what should we call the method that looks at the top, that accesses the top? What should we call the property? Well, I have a really simple suggestion for you. Top. Bizarrely, we break outside the metaphor even when it answers our questions. If you look at something like C# and Java, they use peak. That is absolutely wrong. Peek is a verb saying, we're going to have a look. No, you don't have to look, it's just there. I don't have to do anything special. It's not like secretive, it's not you're doing something secretive and clever like peeking. Peeking is a kind of like a secretive action. There's nothing about that. Stack has a top, otherwise, how else do you get it? Now, there is possible, so this is a no. A possible one is another word in English, peak. Like a mountain peak. No, don't do this. Now you're being too clever and it's not funny. Somebody in future will not like you for this choice. So let's not do that. Oh, this one. Any Java programmers here? Okay, there's some people who aren't going to admit it. No! This is just wrong. There are classes out there, there are APIs where everybody's getting things. I have some very bad news for you. In English, get does not mean I'm asking you a question without a side effect. That's not what it means. When I get the top, it means I take it. Get, in English, means change the state of. Okay? I'm just going to give you an example, a demo, without trying to break anything. I'm now going to get the controller. See, the state of the podium changed, the state of my hand changed. You get married, your marital status changes. You get money from an ATM, your bank balance changes. Disappointingly. The state of the machine changes. Get means change the state of. We call get top wrong. We call get top hot. The other one is push. Now, there are other things we can do here, but what we've got here is a really nice little example of a system of naming that follows. Does this mean we've solved one of the hard problems in computer science? Given that there are only two, cache validation and naming. Did we just solve the naming problem? And we know it's a real problem. This wonderful one in commit strip. If you've not looked at commit strip, there's some great cartoons there. Data, no, too generic. I've seen variables called data. I've also seen variables called data too. Not good. Too generic, data DB, unclear. Let's say list complete already used. Array lists complete the now. We must choose now or the client might cancel the project. Well, array list completed from form will have duplicate. Too long. Somewhere there's a Java program going, oh, that's just right. Unable to name a variable, they go bust. I don't know that this has happened, but no, we have not solved this problem. One of the things that came out of this work, there was a general consensus in the focus group that metaphors can be highly expressive, but to actively seek them might be too forced or result too contrived. It also explains why it is that sometimes when people have proposed a system metaphor, this is something that Ken Beck proposed in his original draft of Extreme Programming. The idea of system metaphor, every system must have a metaphor. You ended up with some really bad metaphors being used, they were too forced. Kind of let the metaphor come. If it doesn't come, that's fine. If you spend your whole time sitting around like those guys trying to read the perfect metaphor, you will not find the perfect metaphor. So it's not always good. So let's go back to network. When we look at network, there are a whole load of things that are true of networks as we think about them that are not true of the original metaphor of a web of material. Okay, when we think about the network, we think about distributed systems, then we immediately encounter Leslie Lamport's observation. How do you define a distributed system? It's one in which the failure of a computer you didn't even know existed could render your own computer unusable. We've just had that with the AV system. The AV system is the one that's now suffering. My computer is fine, but the power spike messed it up. I didn't know. What was that? In fact, my publisher a couple of years back had this problem. Fires in California. Due to fires and power outages in California, O'Reilly.com is unavailable. You can't read your book in Pennsylvania. Completely different state. Oops. That's what we mean by distributed system. There is indeed a theorem, Brewer's theorem, which is better known as cat theory. Now, funnily enough, I was talking about cat theory a couple of weeks back in Antwerp with a couple of people at a conference, Hannes Lovett, Vagev Abeloff, and Anita Sengupta. Anita Sengupta is not a software person. She's an astronautical engineer. And I just mentioned cat theorem, and she said, cat theorem? She's a cat person. So you hear what you want to hear. I said, no, cat theorem. We'll get back to the cats in a minute. So what does it stand for? Consistency, availability, partition tolerance. That's what we're looking at. Now, what is interesting here is that consistency, what does that mean? It means that every time I request a data value, wherever I am in the network, I get the most current version. And wherever I am, we all agree that that is the most current version. We all get the same value. Or we get a failure. You either get the latest or you do not get a value. I'm sorry, this is not available right now. Availability. What's that? You always get a value. But it might not be the latest. This is a cache coherence problem. Yeah? A distributed system, you have one inside every computer. Okay? Partition tolerance, probably not the most clearly named one. Partial failure. Things can fail in a network, as you may have noticed. Can your system keep on running? That's the question. It was at this point, during the conversation, while explaining it to Anita, that she said, wait a minute, it's tolerance. That's what you've got. Oops, I just lost the focus on this one. She noticed that it's tolerance. Therefore, we do have cat theory. Awesome. Now, why am I talking about cat theory? Because you can have two out of you can have 2 out of 3, you can't have all 3. Okay? You can have consistency and partition tolerance. In other words, the program can keep on running, you just won't get any data from it, but it won't crash. Alternatively, you can have availability. It'll keep on running, you'll always get values, but they might be out of date. Or you can even have consistency availability. It means you always get the right values, but the minute anything crashes, everything crashes. This is the least useful one. But it also seems to be the most popular. So, what have we just discovered? We've discovered that in a network, unlike a web of material, we have a boundary on our knowledge. The Hitchhiker's Guide to the Galaxy, Douglas Adams observed, we demand rigidly defined areas of doubt and uncertainty. That's what the cat theorem is. The cat theorem is basically Heisenberg's uncertainty principle for the network. Okay? There are limits to what we can know. Now, this is important because when we come to judge the quality of a metaphor, is it good, is it not good? I wrote this piece a couple of years back for O'Reilly Radar. To be considered good, a metaphor has to offer a number of points of useful correspondence. I'm not going to say how many, but it must offer some useful points. If it doesn't, it's not much use. Another quality of a good metaphor is that it should not have too many obvious points of conflict. You will have points of conflict, but if they are fundamental, that's going to completely derail how we talk about things. We're always going to be distracted by this. But there's also a third point. It must be familiar. Otherwise you're going to end up with a problem that one of my colleagues once discovered, trying to explain graphical user interfaces to mainframe programmers. Well, actually, he wasn't trying to explain graphical user interfaces to mainframe programmers, he was trying to teach them object-oriented programming. And he used graphical user interface examples, except none of them had used a graphical user interface. So now, he was explaining the mapping in terms of, he had to explain the basis of the metaphor in order to explain the thing that he wanted. At this point, your metaphor has failed, because it's not known to the audience. Let's go back to the cats. This is my rendition of Schrödinger's equation for the cat. Schrödinger's cat is both dead and alive. So I mentioned quantum mechanics, I mentioned the uncertainty principle. Let me talk about a failed metaphor I heard about a few years ago. There was a codebase. Now, I didn't see this code, I wish I had. There was a codebase that was written by some developers who also worked at CERN. And they had written an accounting system. And they were looking to sell the source code. And another company went and evaluated it. It turns out that they had used, in the source code, as their defining metaphor for accounting, they had used the standard model of particle physics. Nobody understood what the code was doing. It wasn't that the code was wrong, it was just incomprehensible, because you needed a PhD in particle physics in order to understand accounting. Accounting is not that hard. I mean, accounting is hard enough, you need qualifications, but it is not quantum hard. You've got to speak to your audience. So let's talk about how we talk about issues in code. This is a very long-lasting legacy system that we have in the UK. Since Brexit, it is one of our most advanced pieces of technology. It was built 4,000 years ago. It uses a monolithic architecture. We have no idea who built it, we don't know why, but twice a year it works. What are the challenges that we face when confronted with code that we don't understand, or code that we might consider bad, or of low quality, or legacy? These are not all the same thing, but there are a kind of working definition of legacy that many people have is, oh, it's bad code. How do you know it's bad code? I don't understand it. Someone else wrote it. There's lots of definitions. I'm not going to explore those, they're fascinating. The term, by the way, legacy itself, is a metaphorical use of the term. It entered the English language for technology in 1989. It's actually quite a young term. But it tells you in the 1980s people started discovering, oh crap, there's all this old stuff. And that was over 30 years ago. We've got 30 years extra old stuff since then. How do we talk about this stuff? Well, spaghetti code. What are the first phrases? Okay, this dates to the 1970s, possibly the late 60s. The problem with this is that it doesn't really work very well, because I quite like pasta. I like spaghetti. Spaghetti is not a bad thing. In fact, when people start doing pasta as a software metaphor, they end up with good things. Okay? Oh, you want lasagna architecture. It should be layered. You want ravioli architecture. I first heard that in the 1990s. Ravioli architecture used to mean objects, you want objects. Then ravioli architecture meant you want components. These days people use exactly the same thing, thinking they discovered it for the first time, microservices. But all of these are, in one sense, we're trying to say something good. So pasta is not intrinsically a bad thing. I don't think this helps us. It's a common phrase, but it doesn't give us a metaphorical language. Code rot, software decay. We sometimes see these. These are not as commonly used now, but they used to be used a bit more. The problem is that these are natural processes. If I leave code alone for a long time, it does not decay, it does not rot. The world around it might change, but it does not change. There's a natural process here that is missing in software, so it doesn't quite work. Software entropy, one of the things I discovered when I thought this was a great metaphor when I came across it, but I had just got a degree in physics. Of course I thought it was a great metaphor. It turns out when I was talking to non-physicists, I first had to explain entropy, at which point you know your metaphors fail. Yeah? Technical debt, ooh, that's a popular one. Unhedged call option, what? I'll come back to that. Housework, ooh, that's interesting. There's lots, by the way. So, there is this popularization of the term technical debt. It's a wonderful metaphor, there we go, the word metaphor. Developed by Wood Cunningham. In this metaphor, doing things a quick and dirty way sets us up with a technical debt, which is similar to a financial debt. Now, what is interesting is that the debt metaphor came about in the 1990s. I remember it was called different things. It was called design debt, quality debt. It was also called technical debt. Ward never actually called it technical debt. But the debt metaphor is certainly, we can pretty much pinpoint it to him. But what is interesting here is that we have ended up using technical debt to mean bad. And that's not what Ward meant. So how did this happen? Well, there's a slight nudge here. I mean, obviously many of us have a negative experience with debt, but actually there's a nudge here if you look at how Martin worded it, quick and dirty. In the original article, he repeats quick and dirty, quick and dirty. That is not a positive thing. We are already saying that this is a bad call. It's a bit of a quick fix, we know it's good, and it's just like, dirty is a very suggestive word. So what this has ended up, this slight nudge, means that people always use, when they say technical debt, they mean bad. What did Ward actually say? He said back in 92, so 30 years ago, in fact almost 30 years ago this month, in Uppsala 92, shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. What Ward is talking about is the use of debt as an advantage. But you pay it back because the act of having a debt is an act of borrowing. We seem to have missed out on that. It's an act of borrowing, and you do it for short-term reasons, or even you do it for long-term reasons. So my wife and I, many years ago, we bought a flat, then a house, then another, moved to a house, and then we basically own our current house. We've got a mortgage. It's a 30-year debt. We use that to our advantage. It was structured, it wasn't messy, it was not quick and dirty. It was a strategic and intentional thing with an understanding of all the trade-offs that were involved. We used it to our advantage. Now we have a pile of bricks that's structured in a way that we can live in it, which is nice. But Ward wasn't saying it's bad. What he did say is bad is the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. He's told you that this is the bad thing, but he's not telling you that's the point of the metaphor. Some debt is good, some debt is fine. So, we have this rather interesting challenge. But people have misunderstood this. And I see people quantifying their debt in lots of different ways. There's a lot of misunderstanding. Technical debt is not the cost of repaying the debt, it's the cost of owning the debt. I've seen people try and turn the debt figure into a monetary figure. You can't do that. It's bad science. But there are tools that will do it for you. We have automated bad science. Well done, us. Oh, you now have hundreds of thousands of euros of technical debt in your code. You can't know that. You just made that number up. I can make that number up, and I can do it more cheaply. Fabricating numbers as a service. The point there is you need to, it's not that simple. So when I talk to some people, oh no, we don't do that. We quantify our debt in hours or in days. In other words, how long it would take to repay the debt. That's not the same. The whole point of the debt metaphor is it's the total cost of ownership. Debt is a complex financial instrument. The message of the technical debt metaphor is not a measure of the work needed to repay, it's the additional time and effort to the past, the present, and the future. Notice I'm just using a physical way of describing time. Past is behind me, present is now, future is that way. Yeah? Some cultures have it the other way around. Okay, the past is in front of you. Why? Because you can see it. I can remember the past, but I cannot remember the future. I cannot see it. It's perfectly logical. Just surprising if you're used to one framework. So in other words, we end up using this technical debt metaphor or abusing it. So this leads us to this observation from Steve Freeman. Bad code isn't technical debt, it's an unhedged call option. There's a problem with this. It's not that it's wrong, it's just that most people don't understand it. Steve works in banking. He understands derivatives trading. I understand that when people talk to me about derivatives trading, my eyes glaze over. That's my understanding. I understand with derivatives trading that people are betting on a bet. It's like NFTs. But actually NFTs are not as substantial as derivatives. So the problem is, it's not that this is inaccurate, it's just that it fails the third criteria, which is it's not familiar. But it might be to one of your audiences. If you happen to be speaking to a bunch of finance people, a whole load of people in fintech, this is actually a really good way of looking at it. Here's another observation from Yvonne Lamb. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt, but we can't use it because tech has been made up of people who don't do housework or manage housework being done. In other words, it is not familiar to the people who could be communicated that way. But what we also discover is that we cannot say that there is a true thing. There is a quote from Emile Gasciati, there is nothing more dangerous than an idea when you have only one idea. Okay, it's a good rule for life. But here's a point. We observe, although a metaphor may successfully capture a part or some aspect, coverage of most concepts is improved by explaining them through multiple metaphors. Sometimes you need more than one point of view because it's an approximate mapping, it's not a perfect mapping. You may need for a different audience. Okay? Software development is a human activity, it's actually not a technical activity in that sense. Working with mixed metaphors is the norm rather than the exception. So the idea of having one unified metaphor for everything is probably going to fail every single time, whether it's the standard model of particle physics or not. So, for me, one of the things that I came to recognize is that we've distracted ourselves when we talk about technical debt. Because the problem is not the debt, it's how we got it. Are we managing it or are we mismanaging it? But also, what does it indicate? In many cases, what we want to talk about is instead technical neglect. There's physical neglect, emotional neglect. These are the things that exist in the real world. And then there is technical neglect. That is the problem. It's not necessarily the debt, that's an effect. It's the cause we need to tackle. I find this whenever I work with teams, and they always say, what do we do about our technical debt? We need strategies to fix what we've got. I was given two sets of recommendations. One is for dealing with the technical debt. The other is how to stop producing it. You know, if you're in a boat, and there is a hole in the boat, and it's taking on water, and you have a bucket, and you are emptying the boat. Well done. You've got half the problem solved, but you're still taking on water. A lot of teams never ask the really important question is how do we stop producing the problem that we're trying to fix? Turns out you need two things. Neglect is what caused us to be there. So, let's kind of take this on the home straight. How do we talk about our discipline? There's a lot of words in software. We talk about engineering, craft, science, computer science, manufacturing. Manufacturing is an interesting one because a lot of the time people use it from the management perspective. I think this is particularly dangerous because we solved the manufacturing problem in software a long time ago, in the 1950s. You want a program that does exactly what that program does over there, exactly the same behavior, using exactly the same technology. Okay. Here, have a copy. We solved the logistics problem. Or, here's the plan. This is the source code. I have 1 million lines of source code here. You want that? Just build it. It's called a compiler. That was the first real moment of manufacture. We solved the manufacturing problem many years ago. The metaphor can apply elsewhere in the process, but you have to do so very carefully because it has more points of conflict. Architecture is a really popular one. And in fact, that's actually one of my triggers. So James stood up just before and kind of told us about how we should relate to the world. One of my key inspirations came at the right time. At a conference in 1999 in Oxford, James did a session, Architecture as Metaphor. And that was just around the time that I was really bubbling with these ideas. It's actually what caused me to go and look at the Lakoff and Johnson book. There's a lot of really interesting ideas. Funny enough, I didn't actually come away with the impression that I didn't come away thinking about architecture as a metaphor. I came back thinking about everything as a metaphor. What about music? How do bands produce music? When people say, what is the right way to produce software? I suddenly thought, wait a minute, what's the right way to produce music? Is there one? No, that's a stupid point of view. I like music that's produced by one person. I like music that's produced by orchestras. I like music that's produced by 5-piece bands. And what's the right piece of music? I like music that's 2 minutes long and 2 hours long. It also opens up your thinking. Gardening. This also tells us something else which I think is valuable. When we look for the origin of a metaphor term, sometimes we can find it. Sometimes we can't. Because of the nature of metaphor, it's not like coming up with a piece of jargon. It's not like somebody coins a phrase and that you can say, oh, that person created that word, they created that technology. No, the phrase DevOps, we can actually pinpoint where it came from. It's clearly not a metaphor, it's a constructed word. But metaphors are not like that. Metaphors are not so much, it's kind of like the multi-regional hypothesis instead of the out of Africa hypothesis. They emerge simultaneously, independently in multiple places. So one of the houses, so the first house my wife and I bought, we moved from our flat to our house. I realised when we were working on the garden, this is a lot like software development, or how software development should be. Software development as a garden. You try things out, you cut things back, you see how they work. If that doesn't work, maybe it's not good for this garden, but it could be good in another garden. It's context specific. And you need to take time. Time is the missing ingredient. Time is fundamental to how we need to think about this stuff. And I remember I was using that in workshop, but sadly I never wrote it down. And then 2 years later, it was published in Software as Gardening was the metaphor in the pragmatic programmer. Now, they didn't steal it from me, because it's not a thing I can own. But metaphors emerge. We actually find many of these have emerged many, many times in parallel, independently. But that also brings on to an interesting point here, property. To what degree do you own an idea? Is software property, intellectual property, things like that? That's kind of an interesting one. So I want to kind of close with a thought about that, because digital artifacts are everywhere. And so there is this idea of, just do that. I have to work around. There we go. What is the nature of property? Physical property is mutually exclusive. You can actually enforce that. If this is mine, I can basically say I'm using it and you can't use it because it has physical exclusion. That doesn't work so well for intellectual property. Okay, if you use an idea that I have, it doesn't take it away from me. It turns out that's also true of digital artifacts. If you want a copy of code that I've got, I can just give it to you. There is no logistical cost. There's a few electrons, but there's no real major logistical cost. In other words, it's fungible. Everything in the thought space, all of our thinking, our ideas, and our products are actually all fungible intrinsically, whereas the physical world is not intrinsically fungible. What's fungible mean? It means I can just freely interchange things. Everything's substitutable. Now, if I'm using the word fungible, you know what's coming next. I'm only going to do this because I want to talk about non-fungible token. A lot of people have had to learn the meaning of the word fungible because of NFTs. NFTs are based on blockchains. The best description I know of a blockchain is this. It's irrevocable. The problem, however, is that there is a flaw. There is a deep flaw. I'm not going to make any social commentary on NFTs, except you're a sucker if you're putting money into them. That's social commentary. I want to talk technical. How do NFTs work? We've got an irrevocable transaction. Excellent. Of what? You apparently now own something. You own a digital artifact. No, you don't. You own a level of indirection to a digital artifact. This is a pipe. No, it isn't. It's René Magritte's painting of a pipe. That's why it says this is not a pipe, because this is not a pipe, it's a painting of a pipe. But no, this is not René Magritte's painting of a pipe. This is a photograph of René Magritte's painting of a pipe. So here's the interesting thing. What is it that you own with an NFT? You own a copy of the receipt, but you don't own the thing. You own a level of indirection. If anybody says you now own a digital artifact, it's not in the NFT. What you have discovered is that for NFTs to work, you require all three of these to be present. You require that we have it's consistent and available. In other words, we all agree that Kevlin owns something here. And we can always agree, and that information is always available. Oh, by the way, that thing you have a level of indirection to, for it to have any value, it will always be there. You see, we require three, you can only have two. So basically, it breaks the laws of mathematics, physics, networks, and all the rest of it. NFTs don't work for technical reasons, nothing to do with social reasons. So, the observation here, yeah, cats. No. The observation is reality cannot be ignored except for its price. I want to close with this thought that with this means metaphors are neither good nor bad, just we need to recognise when we think about them that we might actually be working with something else. There is a word that is not common. I provided a definition a few years ago on the page that I run where definitions of language are current. Metaphor. An unusually extended metaphor, where a figurative expression or contrast is made against a metaphor rather than against a reality. A metaphor is therefore two levels removed from reality. A metaphor is in essence an assumption built on an assumption. How much of software development is an assumption built on an assumption? Even moving outside the metaphor space, think about that in terms of the truths that you deal with and test and discuss in conversation. This is only a problem if it becomes a problem. In other words, if you're not aware of it. Of course, this observation is not even remotely new. This is 1980, Meyer Lehman. Any program is a model of a model within a theory of a model of an abstraction of some portion of the world. Or so. I think he had the most fun writing this sentence, because I had the most fun reading it. The funny thing is, I had a chat with Nat Price a few years ago online. We were both talking about the same paper. And we both said, oh, and you know that sentence? Yes, I know the one. Yeah, it stands out. It's a lot of fun, but there's a lot of truth in it. So on that note, I want to just leave you with these thoughts. That the whole idea of metaphorical thinking is innately natural, but we use it much more consciously and ubiquitously in software because software is not the physical stuff that we are used to in our everyday experience, for which we have a natural physical bias towards and an understanding. That means it can be filled with surprises. it can be filled with misunderstandings and contradictions. It's also built on another layer of assumptions. The metaphors are themselves built on metaphors. When you see all of this, it becomes a bit more comfortable and you know what to watch out for. When you don't see this, you will always stumble. So hopefully that will give you food for thought. Thank you.